Hello and welcome to Aerospace Testing International's first Ask the Expert event. The topic of the event today is non-destructive testing. So this session is going to last for 90 minutes and is basically in the form of a live Q&A. But we have had some questions already submitted by the readers, and I will be asking those during the first section. During that first section, if you're watching live, then please do submit any questions that you have as they occur to you. You should see a box on the right-hand side of the screen that you can submit those questions to. When I ask them, I'll publish them, and one of our panelists can answer them. Also, on the right-hand side of the screen, you'll see a tab for handouts that have been submitted by our panelists. So please feel free to download those during the session as well. But first, of course, I'd like to introduce the most important part of this event, the members of the panel themselves, who have been selected from leading suppliers of non-destructive testing products and services. So on the panel today, in no particular order, we have Rick Gerads, who is General Manager at Element Materials Technology. Rick has 30 years of experience in NDT across several different industries, but luckily including aerospace. He has been a general manager of Element's Rancho Dominguez facility in Southern California since 2012. He is ASNT Level 3 certificated in MT, PT, RT, and UT. Hello, Rick.
Hello. Nice to meet you.
Good to have you. Thank you for joining us this morning. Also with us today, we have Naveen Nair, who is Product Line Director, Digital Inspection Solutions at Waygate Technologies. So Naveen is responsible for digital transformation at Waygate, which is an integral part of their strategy to help their customers detect defects and to avoid defects. Before joining Waygate in 2016, Naveen worked for ANSYS and was also part of the research faculty at Michigan State University. Hello, Naveen. Good stuff, thank you. And then we have Miguel-Angel Ruiz, Souza, who is Senior Key Account Manager.
Like Miguel.
Miguel, sorry, Miguel, that's fine. I don't know why I have your name so long. That was a bit embarrassing. Miguel is good, works for me. Miguel is Senior Key Account Manager of Aerospace at ZEISS International, where he's been for 25 years. And he's been responsible for aerospace for the last 5, right, Miguel?
Yeah.
Yeah. But your career in NDT goes back to Philips Industrial X-ray in Hamburg in 1996. Fantastic, thank you. Yeah. And then we have Benedikt, Krist, who is Product Sales Manager of X-ray at ZEISS. Benedikt has appeared on these webinars before, but he joined the CT department in ZEISS in 2016. For a focus project on accuracy specifications of different CT scanning modes. Benedikt is an X-ray CT technology specialist and has been working in CT applications focusing on aerospace projects for the last 5 years. Hello, Benedikt.
Hi, Ben. Thanks for having me.
Hi. Thanks. And also joining us on the line later, hasn't quite managed to get to us for various technical reasons, and sales at VJ Technologies. I'll introduce him when he comes online. So this is quite a general session, really. It's an opportunity for people to pose their questions to you guys. And as I mentioned at the start, we have had a number already submitted. So I'll just start with a few questions that have been pre-submitted. I will address one to you first, Miguel, if that's okay. I think you kindly you volunteered before, so I'll start with you. Okay, and maybe slightly topical. I don't really want to start. Let's talk about COVID a little bit. So, I mean, how has COVID impacted what you do, and from your point?
Okay, of course, all this topic of we can see COVID, it was a lockdown, not only in the society, also in the aerospace industry. And we have the feeling that really the aerospace industry used this time to be more aware about flight zero, what we can do from the environment. And suddenly another industries like e-volts, nanosatellites, etc. are coming more present, more visible for all of us. And of course, the other topic is digitalization. It's not only in the meetings like today, also in the aerospace is winning all the sensors, all what we can control with electronics, and so on, new experience in the cabins. That is something that is going to impact, by sure, also our industry.
Okay. Has anyone else seen any impacts of COVID and what they do or their customers do? I mean, it's or is everyone back to normal now completely?
No, I think we're as a service provider. Obviously, we saw a huge downturn in demand during the pandemic as the manufacturers slowed their production. And but I think we've learned a lot through the pandemic as far as how can we work remotely with NDT and with our customers. So it's we're a long way from back to what was the normal, but definitely on the way back.
I think.
So
I think
is there any?
Sorry, I was about to say. Go ahead, Ben.
Please, Naveen, go ahead. I was just going to say.
No, I was going to just agree with what Rick said. I mean, the concept of normal, I think, has changed. What's normal? So some of you might know we built a high energy cell in Cincinnati that's in product. I mean, that's doing inspections today at a 9 nMeV CT system, and the cell, as you can imagine, has a 2-foot thick wall. And this entire system was built, shipped in pieces to Cincinnati and built remotely. So that's the part people don't know. I mean, we actually did the entire thing with engineers sitting in Germany, engineers sitting in India, hardware engineers in Germany, software engineers in India, construction engineers in Cincinnati, setting this up and doing the entire thing across. I mean, so something that would not have been thought possible. And this is from our side, right, on how we do business. And the same thing has happened for our customers. We do system demos through virtual reality today because, I mean, it's tough to carry a CT machine on your back. I mean, to customers, and so I think the definition of normal has changed, and now we face questions like, okay, even if you can travel to a site, do you need to? You know what I'm saying? So, and that kind of shift has happened across the world, and everything is becoming digital now. That's it's got its pluses and minuses. Yeah.
I guess what we have seen throughout COVID now is like that. Of course, there was a big downturn in the industry, so some investments got postponed or maybe completely discarded. But right now they're ramping back up. Investigations have gone on throughout COVID the whole time. So now they dig deeper into the different technologies. And I think now finally, as the business in the aero industry is also ramping up again, we will see investments in new technology as well there. Yeah.
Okay, great. Thank you. I'd just like to throw obviously a more technical question in right now from one of the readers. This is a question from Joseph Uha, who is asking about X-ray imaging. He wants to know how much is X-ray imaging being used in composite material inspection, and what are the kinds of defects or properties of composites that can be detected by X-rays. So the question really is about X-ray imaging and how it can be used in inspecting composites. Anybody want to have a go at answering that, please? Who's the most qualified?
I believe there is a lot of topics. One of them are related in the space. Rockets, aerospace is also winning some parts in the rocket business, so that is very important to see the fiber orientations, the laminations, the quality, even the fiber itself. And also at the same time, all the body of the airplane. So that's composites, things with self, weight, less weight, etc. And we know with CT, you have a lot of different tools, software capabilities to do a lot of different analysis on composites. I would say it's the state of the art today. But there are some of people with deeper knowledge on CT trajectories, and like Benedikt, for example, I'm sure he can add some additional comments. Yeah,
so I don't know if the audio only on my end was a little bit Did that?
No, I
got
think it was for me too. Yeah.
Okay, so sorry, maybe I didn't get everything you just said, but I tried to add a little bit.
Yeah.
So I think so in CT there are different technologies as well. So CT isn't like CT. There are CTs for doing more like a macro inspection of the complete component, doing measurement, maybe also seeing at least some delamination inside of a composite material part. But if you really want to see the smallest details, then you should go for maybe also an X-ray microscope, which gives you the option to have an even higher resolution with a submicron resolution, looking at single fibers and tiny delaminations as well. So really, it comes down to what you're looking at and what you're looking for.
Yeah, were you done, Ben? Sorry to cut you off.
Yeah, I'm done.
Yeah, I think on the service side, I still see a lot more requirement for ultrasonics looking on composites. I generally recommend, during the R&D when they're developing the product, that if they want to see, like I said, the very fine detail, then a CT is a great way to go. But once you get into production and you define what size defects you need to find, we do a lot of through transmission ultrasonics and pulse ultrasonics, depending on the type of composite. But yeah, they both go hand in hand. You think the ERT can struggle to see the DLAM that's very easily detectable by ultrasonics, but the small porosity can be harder to detect with ultrasonics.
Yeah, maybe you are right. Maybe UT has a bigger piece of the inspection in production, but we believe that for research and development, especially, CT can be a great tool.
Oh, absolutely.
Yeah, I mean, Rick, you mentioned ultrasonic there. I actually had a couple of questions asking about that, asking why the focus on if we were too over focused on CT and those sort of more complex methods, I suppose. Is it not a case where you've got you're selecting the right tool for the job, right? That's 9 times out of 10. Is that what we're trying to say here?
Yeah, absolutely, and economics becomes part of it too. I mean, as an NDT professional, there's no doubt. I think CT is, if you really want to know what's there, the very small detail, it's hard to beat. It's hard to beat computed tomography. But once you get into a production, which is kind of my world, and you're making a lot of parts, there can be a cost impact that CT becomes a bit much. So use CT on the front end of the R&D, and then develop a more economical. And ultrasonics is very programmable. It's very repeatable. It can be economical to then do your production runs.
Okay, so I mean, staying with that kind of theme, I mean, what are the deciding factors? Because you work a lot with aerospace manufacturers, right? What are the deciding factors that you use to, when you're working with them, to either, should they be outsourcing with you? What technologies should they be selecting? How do you help them through that process?
Yeah, with the decision of insourcing and outsourcing as a service provider, obviously a lot of our customers also have their own NDT capabilities. I think the business decisions, time and money, right? Time, to me, a rework loop on a manufactured product is a big deal. Like the casting world requires radiography and penetrant often, right? But there's very often there's a requirement to find defects, to remove them, to re-weld them, and if you send them back and forth to a test lab like Element, you can lose a lot of time during that back and forth, right? So that's a decision. If you do forgings don't have as many defects generally, so it's easier. We see less forging companies have the internal capabilities. They prefer to send to a lab where they can get a firm fixed cost and there's very little fallout, right? And welding can go either way. I've seen welding capabilities where you have very, very few rework loops, but also some that have high rework loops. And then the other big part of the cost when it comes to insource or outsource is the quality infrastructure, right? If you, as a manufacturer, have to keep the NADCAP certs and the personnel certifications and the trainings, and you have a very diverse, product base that goes out to a lot of primes, you have to employ a lot of people in order to have those approvals and go through a lot of audits. I mean, as a company, Element probably goes through 30 plus audits a year by the primes, which then allows a lot of customers to utilize our services. So yeah, it's cost, and the cost is kind of a personnel and it could be a CapEx decision, but a lot of it's also the time on the rework loop.
Yeah. Okay, great. Thanks, Rick.
So
I just wanted to pick up. Sorry, Naveen.
No, I was wondering. I mean, and maybe Rick, you know this better than I do. Isn't there's a regulation part of it? I don't mean just an FAA kind of regulation, but there's also, for example, if let's say Rolls-Royce or GE Aviation has a certain standard on a part, half the time they also define the testing that is required to accept that part, and then that means that the tier 2 supplier, PCC, Howmet, and so on, will need to supply the part to that specification, and that sometimes dictates the quality, and that's something we often find, you know, with especially in my role when you're trying to transform people into, you know, the digital world or whatever it is that you want to call it. You know, we can throw buzzwords at it, but at the end of the day, we come back to the question of, okay, if I build this part and test it the way you are telling me is the really cool new way to test it, will it get accepted by my buyer, so to speak? And I think that's a reality that we live in, right? And it's part of the equation that we have to factor in.
Okay, but
I think just to follow on that a little bit, I think part of, you know, I love the aerospace side of the non-destructive testing, but it does move at a very slow pace. I think, you know, our technology comes along, and then being able to use those tools that we know as professionals would really add value can take a long time to get approval. And that's with digital radiography, CT, the advanced ultrasonics things.
Right.
I believe this is really one of the paradigms in our industries. High-end, absolutely from the technological point of view, but at the same time, it's very conservative. So every step costs a lot of efforts, a lot of thoughts. Nevertheless, we are flying today with the technology, what is maybe 40 years old or even older, is just an optimization of this chain production. But it's really, we are flying, or most of the flyers are still on basis of old technologies because the industry is just so conservative. Of course, we are flying people, and we need to take care of the people, and maybe that is the major reason. But in some moment, I believe a little bit more challenge, a little bit more, okay, let's try a little bit quicker, could help all of us.
Absolutely.
Okay, I'd just like to take this opportunity, guys, to introduce Wes, who's very patiently waiting in the corner of my screen. He was a little bit late to the party, but he's here now. So Wes is from VJ Technologies, right? Wes, you've only just joined, right? Can you just tell us a little bit about yourself?
Yes, recently joined VJ Technologies 2.5 weeks ago. So this is actually my third week here. Looking forward to it. It's fun to meet the team. They have a lot of talent here and some great things going on that I think will be a benefit to the industry, especially in the aerospace sector moving forward. So thank you, everyone. Sorry for the stepping in a little late. We've been trying to deal with some technical firewall stuff here for about half hour. Finally got figured out.
No worries. Okay, that's okay. So we're just talking about CT actually, and where it fits into to work. I wanted to pitch this question here while we're on the topic from the audience that John Hansen's submitted. Thanks, John. So we're obviously talking about using CT at the front end in R&D, but what about in maintenance where the majority of aerospace NDT is undertaken? I mean, is CT ever used for that in that area? Anybody want to take that?
Yeah. Sorry, go ahead, Wes.
Oh. Okay. You know, on that one, I think it's a growing interest as well, because not only just in maintenance of the parts, but some of these parts on aircrafts, not only verifying that they're good, but now you're able to use additive manufacturing processes to add to some of the material on key parts. Airbus had a part that they did this, and they're able to do it 3 different times, where they were able to add the material and then machine it down, and it increased the life of that part, so they could use it 4 specific times before they had to scrap it. The cost savings on that I cannot remember, but CT was the verification process after the additive material was put in play.
So I think one of the things that maybe we and I notice in that team that we have assembled here is maybe a little bit missing, is the visual inspection aspect or boroscopy, right? So a big chunk of standard maintenance inspections, the so-called on-wing inspection, the C checks and D checks are done using boroscopes. So old-fashioned looking at images. Now, my Boroscope product line manager will kill me if I call him old-fashioned, but bottom line is, he will say that he can see a 50 micrometer defect in an engine inside a wall of titanium, which is pretty cool. Huh? But I think the point is that there is a lot of boroscopy that is done. There's a bit of ultrasound that is done once you pull the engine off the wing and start taking it out. And of course, as Wes mentioned, CT, X-ray, both of them are gaining some popularity. But I think a large majority, and I should know because half of our business is based on that. A large majority of on-wing inspections that happen, that when the airplane is in the hangar, is done using boroscopes on the engine. There's also some what you would call boutique inspections that are done using things like magneto-optic imaging and so on, where you look at rivets, for example, on airframes, and stress imaging for wheel wells and so on. But yeah, I think largely boroscopy, CT, and ultrasound are still the major players. Please feel free to disagree. This is entirely my view, but it's also a little blinded by the fact that those are the three things we sell most. So,
does anybody want to disagree? Now's the time. No? Okay.
No.
All right.
Well, I think Eddy Current has obviously taken some big advances, in that direction with array Eddy Current capabilities and what they'll be able to do with the probe design. So, still a major tool for in-service testing.
Okay.
Go
ahead, please. Sorry.
I would like to add is we are just speaking about defects. And don't forget, when we are speaking especially about computer tomography, that is also a coordinate machine. So that means with one click, you are solving NDT and you are solving metrology tolerances topics. That is what we believe that is CT itself is the biggest possible sensor. So you are not touching the sample, and in one click, you are solving a lot of different topics. The typical NDT topics we are discussing, but also the tolerances, metrology, all these topics.
Right, and I guess that brings up, we talk about the structure of the airframe a lot, right? And then we talk about the engine, but there's also the wiring, which is usually inspected using pulse echo on electrical signals. There is the hydraulics, which is often tested using simple pressure measurements, and so there are these other aspects of what keeps us up in the air and not subject to gravity, so to speak, that we kind of forget. And yes, the most visible and the most dramatic things are the airframe and the power plant, but there is really a horde of other systems that are also tested regularly.
Great, thank you. I just wanted to introduce another element here from a reader submitted by. We've kind of talked around it a little bit, but it was submitted by a reader, and it's about cost. And we did talk slightly about this earlier on, but it's from Gerads from Volume Graphics. It's a bit of a cheeky question, really. But his question is, are the CT prices ever going to drop? That's what he wants to know.
Are the VG prices ever going to drop?
Yeah, I'm not sure if he's trying to start a negotiation with you all now. Maybe you'd all like to pitch.
Quick answer, no.
I believe we are very quickly. They are the first one. They should drop a little bit the prices.
I would say maybe in an absolute number they haven't dropped, but in a relative number to what the capabilities currently are, of course they have dropped. I mean, yes. The technology, new systems, the price for new systems was very stable over the last 5-10 years. But what the capability of the system is, this has definitely increased. So what you get out of it for your investment, you will have way more productivity. We'll see with a CT, especially way more details now with higher resolution. Scanning times have improved and so on. So I think from a relative standpoint, yes, the CT prices have already been dropped.
I fully agree with you, Benedikt. Absolutely right.
Yeah, no, absolutely. I think there's also the idea, of so yes, we look at it as Benedikt said. Obviously, the capabilities and the performance has dramatically improved. But I think there's also an aspect of, we keep talking now about production level CT, right? So I think somebody brought up the idea of CT being used in R&D. There's really a bunch of activity that is going on around bringing CT machines to the speed and capability of actually putting them in a line. I mean, so when you talk about 1,000 automotive parts per hour, there are CT machines today that are capable of inspecting them, and I think that is really something that, and I believe from all of us suppliers. I mean, not just Waygate. I mean, I think so. I think it is really important to recognize the level of advancements we've made, and how that value can be turned around into what we think of as cumulative value, right? So you just don't get the CT inspection as a quality check. You also get that information, the data, to be able to feed that back into your production line to actually improve your production systems. And so those kind of multiplicative values are something that we get for the same or similar price, because as Benedikt said, the prices have indeed stayed largely consistent. They've not grown at the rate of the capability at all.
And what I really believe is one of the aspects when the people see the technology like it's very expensive. One, you have the investment capital, the capital investment for the system. On the other side, you have the very good educated operator. What you need to analyze all the results. And I believe with all these topics what are coming to all of us, artificial intelligence, etc., if we are able to do a very easy and we apply a little bit of artificial intelligence and we do the analyze, much more simple, we are able to simplify what are the interesting information for this customer in particular, and we reduce all this process, and suddenly it is an easy process, then it is even cheap, the technology, because all we are offering, if we are able to move with artificial intelligence, simple graphic user interfaces, and so on, suddenly I believe we are moving more into the production, and that is not going to be anymore a topic. What is the cost investment of the system itself?
I mean, that's already done mostly in the automotive industry. So there we've seen that they have gone way further than the a little bit more conservative aero industry, where most of the X-ray radiography, CT scans, and so on, they are still inspected manually. But in the automotive, we already do that. We do fully automized loading, unloading, inspection, evaluation, and so on. Of CT scans in the tech of the production line with 100% inspection. That's what we already do there. And now it's just like time to put that also to the aero industry.
Also in electronics, by the way. I mean, so I think, as we mentioned earlier, aerospace is where tier 2 will not work until the prime is ready, and the tier 3 will not work until the tier 2 is ready, and the tier 4 will not work until the tier 3 is ready, and so on. So there's a big chain of command, if you will, that deals with implementing any new technology, whether it is automatic defect recognition or a faster robot, so to speak.
That is true, but the Material Affordability Initiative group has pushed the things much faster over the last few years. And so when we're speaking on aerospace and we're looking at the initiative from the Material Affordability Initiative, they are pushing things at a faster pace. So now we have assisted defect recognition approved at certain sites. As we see deep learning and AI start to enhance our capabilities in X-ray and CT imaging, I think we'll be able to gain more traction in the aerospace sector based on proven results, because we know that one mistake can be catastrophic for hundreds of people. And an automobile, it could be catastrophic, but it's less likely. And electronics, obviously, it can be catastrophic depending upon what that component is going on. So it's good that they're moving at a quicker pace, but putting quality first as well. So I think we got to remember that in the aerospace sector as we look at ADR and moving to assisted defect recognition, going back to the point at hand, that will lower the cost of the overall CP inspection. But what Benedikt did a great job of pointing out was the software enhancements and what you're seeing on deep learning and machine learning are going to help us improve the process and speed things up as well. So.
And this is a good point. This is one of the reasons why me personally I'm focusing in the nano satellites market, because there are not people involved. So that means that is also, don't forget, that is also a space industry. And they don't have the topic of, okay, what happens if there are not people involved? They are much more open, and they have an absolutely different dynamic in comparison to the big OEMs we know in the typical aircraft business.
Yeah.
And I think they're really inspiring.
I think one thing we should also remember to the point that Wes made. We talk about the so everybody is to use a word excited when we talk about automatic defect recognition, and people start saying you should not make mistakes, you have to be reliant. Now I obviously cannot release the name of the party, but people have done studies on human read defect information, and nobody has gotten beyond 85% accuracy based on recalls. So that is likely the accuracy was even lower, but literally just based on recalls over time, over a 30-year time frame of a part, typically 15% of parts are recalled after a human inspector has passed them. So I think what at least what we are trying to shoot for is to get to beyond that 85%, so to speak, and make sure that we are at least as good or better than a human, because I think everybody will make mistakes at some point, whether it's a software or a human being. And I think it's about how to play the averages.
Yeah, to maybe go on that point a little bit more, if I can, Ben. Yeah, I totally agree with you that and as a person, I've lived my entire life at a service lab, right? We employ people. This is their job. You see technicians start thinking, hey, a robot's going to take my job, right? So it's a little bit scary on that. But I always reinforce them. If we came up with an ADR because if I look at a typical casting with 100 defects or 100 images, 90% of them have nothing in them, right? So if the robot could screen those, and your job is really about everything you look at has to make a decision, your job actually got more interesting, right? And that's where that lack of focus that you talk about, when you look at so many images that do not have anything in it, where the complacency comes in. So I'm super excited about the ADR. I think even as a service provider, you start to wonder, what does that mean for the need for us? But ultimately, that expertise just gets better, and it makes the job more interesting, and maybe changes the talent level a bit.
Right. Oh, absolutely. And I keep when I talk to customers, we keep making the concept, right? So our ADR, we say, is assisted defect recognition before it gets to automated. So it's not kicking your job out; it's just making your job far more easier for you.
Yeah.
Guys, I just wanted to bring in some of these questions from the readers, guys, if that's okay, just to move things along. That we had one kindly submitted here from Dr. Srinivasa Rayo from MQS Technologies about some technology that he knows from the pipe inspection industry called image intensifiers. I don't know if you guys saw that, but they're used in real-time inspection. I mean, we're kind of talking along the same lines here, but with digital, he's asking, with using digital detectors, can we get the same productivity with existing X-ray sources? Does anyone want to address that question?
Yes, I was in the formal days, I don't know, maybe 10 to 15 years ago, Mr. Pipe in the company. So that really, I would say there is no reason today why don't use a flat panel. They are quick enough, they have a better contrast, better spatial resolution than the image intensifier. I would say new requests nowadays, by sure, they are not going to use image intensifiers anymore. That is technology from yesterday. The only topic is, and even the size of the flat panels are smaller. You can go in smaller diameters. I would say absolutely no problem to fulfill all APIs, 5L standards. I don't know what is the edition today with a flat panel.
Anyone else want to add to that, or shall I move on?
So,
Please.
So you can add digital cameras to the back of that have frame rates that are amazingly fast. And there are certain applications out there I would never rule that out for. Most of your aerospace, as far as quality testing, I would agree. Flat panels are what you should be using because you're going to get better signal noise and contrast to noise ratios. But when you're looking at some ballistics testing or different things where speed is part of the factor, we should definitely make sure that there is still options out there to do some testing that flat panels do not allow on the frame rates that you can attach with cameras nowadays.
Okay, great. And just another reader question that's been pre-submitted by David Perez from the SPAF Engineering Division. And this is about direct digital radiography. And he would like to know that for direct digital radiography, what is the flat panel micron size needed for fatigue crack detection? So we're getting into some real techie questions here. You're all smirky. This is a difficult.
This is a question you face quite often in industry, and there's a lot of factors. Obviously, and that's why everybody I think is laughing, because it comes down to focal spot size paired up with magnification, size of the part, and also the pixel pitch of the detector. If it's too small, can actually be detrimental based on contrast sensitivity. And then your distance from tube to detector, being able to lower your KV to increase that contrast. So it's a very in-depth question, but there's a lot of things to consider. I'll let Benedikt look like he wanted to talk on that a little bit as well.
Yeah, go Benedikt.
Yeah, so I mean, I don't have anything to add there, because it really comes down to the specific application, the system, the detector, and so on. The magnification should all be targeted to the application, to the defect sizes we're looking at. Material we're looking at. So yeah, it depends. That's the right answer. It depends.
Yeah, I was about to say. I think
which industry doesn't like.
Yeah, of course.
So maybe Ben, just to understand the question, was he looking to detect fatigue or fatigue cracking?
Fatigue cracking.
Okay.
Yeah.
Because if you're looking for fatigue, the problem suddenly becomes a lot more complex. But anyway.
Okay. I mean, he's also written here. I mean, which is he wants to know about standards as well. Which is the ISO ASTM standard for that application? I mean, I guess it depends what he's set, what exactly he's doing, and what would be the best phantom standard for DDRT. So, it's a quite big question. Does that make sense to anyone? Does anyone want to take the rest of that question?
Yeah, I mean, really, I think what he's getting at is per the aerospace standards. I mean, to determine that you're going to have detectability on the crack, you have to know what that size of the fatigue crack is, and that's very small. And then being able to fit your pixels within a 3x3 pixel matrix inside the minimum defect size you need to detect. Fatigue cracks are very small, and the proving out a detectability and making sure that you're getting the proper resolution would mean some super high magnification when you're dealing with starting cracks versus truly formed cracks. And that's where experts like the team at Element, who have years of experience in working with customers as well, probably add some to that when they're doing the testing in the field.
Yeah, from our standpoint, it's about how many good known defect standards can you make, right? It's all about the experimentation. I mean, every one of us probably get asked on a quarterly basis for sure, hey, can you find this defect? And they don't like the answer. Not sure until we try sometimes. Yeah. So yeah, I actually think about with additive manufacturing, we've been able to partner and with that technology make some really good embedded type flaws that in the past we tried to EDM and do welds and embed things that if you can make them through additive manufacturing, now I have a true standard that I can then build the technique around to prove that I can do it consistently.
Now Rick is we're too honest these days. It used to be not sure until I try, but yes until I try. Now at least.
But what I believe what here is important is, yes, for the end customers, what is really important is to know my system is performing properly. The other is a topic, what is the job to be done now? Can be sometimes 50 microns, sometimes 1 millimeter. But you need to know that the system is working properly. And I believe that here, all of the different suppliers, we are following very strict regulations, very strict internal accepting procedures that afterwards the customers has to do in a regular basis to be sure, okay, my system is working properly. And if I have a quality topic, my system is able to detect it because it is, let me say, calibrated. And that is really what is important for our customers.
Okay, great. If we finish?
Am I out or did we lose Ben?
Seems like we lost Ben.
Just broke up a minute.
Ben, we missed a little bit there.
Oh,
Just missed you for a minute.
right.
No problem.
Okay, sorry, it must be the Wi-Fi. I just wanted to take this question, another question from the live audience. Can everyone hear me?
Yes.
Yes.
We're good.
Yeah, great. It's from Gerard Carolan. I know this panelists can see it. I haven't published it yet, but I will do shortly. He wants to know about active IRT, which I think is thermography, infrared thermography, in the production of CFRP laminates. Can anyone vouch for it? He wants to know. So I don't know if anyone, Rick, maybe this is a question for you. He wants to know about if it can be used to detect it. It must be because you're laughing.
It's not for me. That's one area.
Not for you.
I do not have.
You don't know about
any experience in infrared.
Does anybody here know about infrared thermography, particularly with CFRP laminates? No.
So maybe. So again, the answer. You know what they say, when you have all of this, you can sit back and say it depends. So he's talking about basically all the difficult types of defects, and I think he pushed a question also asking for kissing bonds. So in general, you can definitely, and I don't want to use these big words, right? But you can probably detect delaminations and voids in CFRPs using active IRT, but it depends on a lot of factors. For example, what is the temperature tolerance? I mean, active IRT, yeah, sure. If you hit it with a large enough wave, you can detect pretty much anything, but you pretty much end up, you lose the non-destructive part of the testing process. So it's a little bit weird. I think, yeah, foreign materials and porosities are a little weird, a little more difficult. I would say voids for sure. Sorry, foreign materials and delaminations are a little more difficult. Voids and porosity, which I'm assuming are relatively similar things, but they can be detected usually using active IRT. Kissing bonds, I wouldn't try it. I think that you can again, there might be better ways to do it. So yeah, I think 2 out of 4. I don't know how that ranks for him, but I would say 2 out of 4 would be things that I would try. But if you're looking for CFRP laminates and looking at defects, yeah, we can start with active IRT. I think it's a good starting point.
Okay. Thank you for taking
Sorry, that
on
was largely a non-answer with a very long explanation, but and that's the best I could do.
No, I think you were braver than a lot of people here, so that's so well done. Thank you. There's a question here from Sergey Anikin. It's quite a long-winded one, but basically he's talking about how CT data can integrate with 3D CAD data. I think. I mean, does anybody want to talk around that? I mean, what?
Yeah. No, so I see a lot of people nodding in the team, so I'll keep it brief. I think there is a large value to this, and that's, I mean, so I'm the one who actually thumbs up the thumb ups, whatever the answer, the question. The point is that I think there is these are the things that we try to do, and we should all aim for, right? As I said earlier, how do we drive added value for our customers through inspections? Because inspections have historically been Q&A steps, right? So you have a part you produced, you have a product you produced, you look at it, you inspect it, you get a result, and then you either accept it or you throw the part out or repair it. The question is, can we actually use that to influence the design, the manufacturing, the process of creating that part, so that in Waygate we use a tagline, taking our customers from detecting defects to avoiding defects, right? And I think a big part of that is the ability to integrate not just the CAD model, but for example, if you have a design system, if you have a functional design of the product, if you have a digital twin of the product, we would like to integrate inspection data into that. And I think that really plays a big part. And like I said, I'll stop there and let others comment.
Yes, that is right. That is, I believe, the vision we have all of us. That in some moment the CT, like a sensor, is middle in the production, is able to communicate with the 3D printers of the environment, and exactly that. We are able to see deviations in the process before there is a defect, and if we are able to communicate in time, then they can to use our information for correcting the setup of the other machines and just to avoid that the defects is coming.
Yeah, I mean, coming to some other topics, I agree with that. Where it may be of interest in like volume graphics, you can bring that CAD model in and overlay regions of interest. And regions of interest can be very important when looking at parts that are scanned, maybe pre-machining, and being able to determine, is there a defect that you may open up so you scrap it before the machining, or understanding that. And even furthermore, as we get into the metrology comparison between parts for measurement, when you put one part to another and we start using deep learning and AI, I think you're going to see CT evolve drastically over the next 5 to 10 years. I still believe this field is early in the S curve, and you're going to see a tripling or quadrupling of this industry over the next 3 to 10 years, not just in aerospace, but also we're seeing a lot more in automotive sensors and different things. And there's obviously a change over there on the electrical vehicles. So I think it's important to understand that what we can use these CAD drawings for could be very impactful moving into the next 5-10 years.
Yes. Even
Okay.
right now,
I just wanted to broaden the question out slightly. I don't. I mean, obviously that's a trend within technology and NDT. That integration of the data. I mean, are there any other trends that we're seeing within the NDT supply chain that anyone would like to highlight? I mean, Rick, have you picked up on any that you see?
Okay, especially if I have a look in our X-ray world, what I see it is in some moment something like a hybrid systems. So that maybe when we go in the area of region of interest CT, that maybe we use the 2D technology just for selecting, okay, I see something that is my region of interest, and now I do CT to get certain results. I believe that is the future could go in that direction, especially if we want to move in the production, because once you are in the production, you have to be quick. And then 2D is going to be always quicker than 3D. So that we need to find an intelligent combination of both technologies.
Okay, fair point. Rick, did you have any trends there?
Yeah, well, my answer is probably, like I said, my other panelists here are much more in the technology side and in the service side. I think what we saw pre-pandemic, when we literally had record levels of demand to inspect high volumes of production parts, which is what my business predominantly is just a lot more partnership with the big tier 2 suppliers, signing long-term agreements so that we as a provider could build the capacity they needed around a known demand. From a lab standpoint, we obviously have a very high volatility of our intakes on a daily basis. So those customers that really want to partner, like I said, I look for innovation. You guys are looking for innovation around equipment, which I love because I want to buy that equipment and utilize that equipment. But Element kind of looks to innovate around how do we partner better with our customers, and those customers that let us be part of their growth really allows us to build a good supply chain base to ensure that they have the capacity when they need it.
Wes, you're nodding your head. Do you see what kind of big changes do you see coming to the market in the next few years?
Well, I mean, I really think what we're facing right now is a labor crisis. and I think we touched on that point earlier, is we have the assisted defect recognition. Everyone knows the age of your level 3s and a lot of the level 2s in the aerospace industry has been on the uptick for a number of years. Luckily, we have brought in some amazing young talent over the last 5 years. You've seen a push for that. So you have a lot of capable level 3s working under some of these level 3s with years of experience. But as we continue to work with the Material Affordability Initiative and driving the capability of making inspection more efficient, it will allow things to be easier. And then looking at disruptive technologies and how that pairs together with some of the other things we've covered today, tying in 3D prints, so CAD or Unigraphics, and being able to look at parts both dimensionally and for inspection purposes in all industries is going to change drastically over the next 4 to 5 years. And then taking that data further to drive it into how it's going to help industries improve, as there's a lot of initiatives in companies on Industry of Things or Industry 4.0, and taking the data we deliver helps them determine the impact of what supplier is causing issues, potentially die changeouts, and expediting some of their processes ahead of time so they don't have as much downtime.
Yeah, I was interested just to pick up on that point about skills and labour shortages. We had a couple of questions from readers about that. One particular from Jake Richter from a company called Pixel. He wanted to know what's being done to address these. I mean, can I just is that a problem everywhere, that all around the world? Is it a problem in the States and in Europe? Are we, it's great having these amazing pieces of equipment, but as Jake says, I mean, who's going to be around to run them in a few years' time? Is it that big a concern? Who wants to go on that first?
I think readers are a concern, at least as far as, converting an image or a CT volume into something sensible that can provide actionable intelligence for the company. That's the role that traditionally NDT level 3s, level 2s have provided, and that is a scarce resource today, and a dwindling resource. I mean, that's something that we've heard, to your point, Ben, uniformly across the globe, across industries, not just aerospace, automotive, oil and gas, by the way, and we repeatedly hear this, right? So whenever we talk about ADR, whenever we talk about automation, we repeatedly hear this issue of, hey, and this is not just the people who read, but you find it in almost weird pockets of the industry. Like, for example, I heard a customer say, I don't have people who can place parts correctly to put into a CT machine. So can you design a robot so that the part positioning is always accurate? And things like that, right? So we get into this whole dwindling skill set of a workforce, and at least, like I said, from our view, it is a problem that begs a solution. Now we are seeing it as an opportunity, honestly, but I think that's a fair point.
Well, Ben, maybe it's time for me to.
This is the opportunity we see, all of us. If you see all our systems, how they were looking 10 years ago, and how they are looking today, is much, much easier today to handle a city system than it was in the past. So that we also are recognizing this demand from the market that has to be easier from the operation point of view. And I believe this topic is right now addressed by all of us.
Yeah, I think one thing we're really excited about at Element is remote reading, right? We have talent in many labs across the U.S. Traditionally, the big investment casting companies don't want to ship their product a long way, so we can have the X-rays taken in a lab near the manufacturer. But then we're starting off with primes. There's an ADCAP checklist now that's approved. You can get approved for. The primes are buying off on it, where traditionally your NDT talent in Houston, Texas is around oil and gas. It's around pipe. It's around welds. And now we've trained up staff down there that are capable and certified and qualified to read aerospace investment casting. So we're super excited not only just domestically, but Element has NDT across the globe. That minus some ITAR issues and that kind of thing, to be able to have images read anywhere in the U.S. So I think that helps with the talent pool. Of course, it helps. We've all learned a ton through the pandemic about remote work and people kind of leaving the big wanting to leave the big city of Los Angeles so they can and be able to live in a different area, but also to use their craft that they learn there. So we're super excited about remote reading and thinking that can really be a change in a way to combat the shortage of talent and labor.
If I may, sorry, go ahead.
I just wanted to address his question to Benedikt, for no other reason than the fact that he's probably the youngest person on the panel. So
thanks. No worries. I'll speak up for myself if I need to. But if I want to come back to what we've discussed earlier already today. We already had discussed, like, do application engineers need to worry that in the future they will be obsolete because AI will replace their jobs? Definitely no. What we will see is having AI, as we already talked about, assisted defect recognition and so on. What we will see is that AI and our software tools will assist the highly skilled and trained application engineers to do their job more productively. So everything's meant to increasing the productivity level of our existing staff, bringing their knowledge further, and making their jobs more easy. In order to get us all together and the whole industry ahead.
Just to use this to kind of swing back to trends that we're seeing, right? I think one major trend that we do see, and I personally am very excited by, is connectivity. And when I mean connectivity, I don't mean just, so of course the remote reading, the remote connectivity, the ability to remote collaborate on NDT data with experts across the globe, that is absolutely coming. And that's, we keep saying, maybe we shouldn't say this considering my Teams crashed 5 times today, but we keep saying Teams or Skype for NDT devices, right? But there is also this aspect of connecting data itself to each other. What I mean by that is, if you take a typical aerospace part, let's assume it's a blade. This blade goes through multiple testing scenarios, all the way from when it was a bar of titanium, when it was tested, or a powder, when it was tested pre-casting, when it was tested at the casting process, when it was tested at machining, when it was tested at assembly into a stand, when it was tested finally, when it became inside an engine and people were doing a boroscopy on it after 500 flights. There is value in connecting all of this data together. Imagine if you were able to connect the ultrasound inspection from a blade and say that there is a misalignment that is not big enough to fail the inspection, but keep that information so that when you do an inspection 5 years later on the same part, you can use that information to make a better decision, make a faster decision. And I think that kind of connectivity is something that is really coming out and becoming valuable to people. And it's something that I think will change the industry the way we see it, because inspections will no longer become isolated incidents. It will become part of a life cycle of an object, of a part.
So Naveen, just queuing in. Sorry, Miguel, go ahead.
Yes, I see also this topic with the connectivity, and at the same time, a resistance at the customer side to share.
Yes.
Especially in aerospace, to share any information with any supplier. So that is really a pretty big strain there. Because
I agree.
More information, we will go forward much more quicker than we are doing today. But that is really a very big topic.
But that's honestly my bread and butter, right? We try to build those secure systems where sharing becomes securely and privately possible with the correct, permissions. And it's a big debate. It's a big. Every time we go to a customer, it is funny, and I often start by asking, you don't want to put stuff on the cloud, but you are sending emails, right? I mean, where do you think that goes through?
No, that's really interesting about Element. Except back to those partnerships with our customers. It's not that we don't want to. It would just become the easier you guys can make it, with your technologies to allow us to do that. That's an amazing concept, to just think of every time that part is tested, that becomes part of the legacy information of that part, and now it sits in a file somewhere that, yeah, it's very difficult to retrieve. That's a very interesting concept.
I just, sorry guys, I just wanted to, sorry Benedikt, I'll get back to you in a second. I just wanted to interpose just very quickly and just say, if anyone watching has got any questions that they want to get in now, now's the time to do it, because we'll be finishing up in about 25-30 minutes. That's our maximum time. So now's a great time to do that if you want to get it through. Sorry, Benedikt, you were going to say.
Yeah, the benefit of correlating different data from different tools, not only sooner or later in the usage of that part, maybe in the maintenance and repair department, but also right during the production, really can add to the level of production quality. For example, if you have an additively manufactured part, a blade, you want to inspect the powder before the part will be printed. You want to make sure that the whole printing process is correct. After the printing process, you want to check if there are any defects inside before you machine it. Then after the machining, you want to make sure that the final machining does have the right metrology specifications, the part, and so on. So and bringing all that data into one place, having one big overarching tool. Like we have within ZEISS, we call this Atlas, which allows you to bring data from a microscope, from an EDM system, from a CT, everywhere together, correlate that data, have a look at it, and evaluate it from like the macro inspection down to the tiniest detail you want to inspect on that part and on that powder whatsoever. So you really can monitor the complete process right from the beginning up until the final part with one big tool.
Absolutely.
So I think we're talking around a little bit about digitalization here, and about the different ways we can adopt it. And from your guys' positions, it's great to offer all these things in digitalization and talk about the benefits. But I'm just wondering, I mean, what are the first steps your clients, the users of these tools and techniques can take to really introduce them? I mean, Naveen, perhaps first this is kind of what you've been talking about. What's the process to go on to adopt? I mean, are we too slow in the aerospace industry to adopt this compared to other sectors?
I don't think so. Let me maybe answer the first part of it, which is the easy answer, because it's right behind my face there. So I think we go as we call it in 3 steps, right? So we figure out how to acquire data, and that's really the key, right? So and then somebody raised a point, I think Rick, it was that it is partly our job to make it almost seamless. I mean, I do not know how many of you have for example Google Photos on your phone, but yesterday I get a notification about some picture that I took 18 years ago, and it pulls out something that I think is really cool. So it has to become that much part of the ecosystem of our customers, and we cannot try to go superimpose. So acquiring data in a seamless fashion from the various tools they currently use, from the new tools that they buy in, and being able to collect and collate all of this data and provide it in a contextual manner is the step 1. And then we proceed to things like analysis, which is, we talked about AI, we talked about machine learning. There's a whole bunch of things you can do. There are ideas like data fusion that you can apply on bringing all of this data together and providing value. And then, of course, there is a concept of how do we act on this information, right? So you take all of these insights that you get and really feed it back. Benedikt raised a very good example of doing this in additive manufacturing. We have actually created a solution where we're able to improve the speed of the printing process without affecting the defect profiles by connecting the inspections of the powder, the in situ inspection of the process of the printing, and the final CT that we do on the part, and feeding information back from these defect and process monitoring back into the process design. So that kind of a closed loop improvement is something that we can deploy. Now, aerospace, yes, it is slow. I don't want to say it is slow. I think aerospace is careful. I think Wes raised the point of things being, a lot of people are affected, and it's a big industry, and it's a very critical space industry. But that said, I think there also the MAI initiative that we talked about a couple of times, the materials affordability, initiative that we talked about a couple of times, are examples of where the aerospace industry is actually leading the pack. Additive manufacturing is another one. I mean, so if you think about it, we built CT machines in the past that could detect, say, and all of us here can argue with each other, but let's say 1 micrometer defects in a 10 centimeter part. Today, we are being asked to detect that 1 micrometer defect in a 10-meter part because they can manufacture that additively. And I think that kind of forcible changes to our technology are coming at us. And the aerospace industry is leading the pack there, and that's I think pretty incredible. Most of the work that we do today on additive manufacturing inspections are for the aerospace industry. I would say a huge chunk, to the tune of about 70-75%. So I think it is not slow. It is careful. It is measured, I would say, is a better word to use as an industry. And yeah, digitalization will come one way or another.
Yes, I mean, there are big 3D printers producers. They are speaking with all CT suppliers in the way if we can define a human interface so that we are able to communicate in a universal way. And that is absolutely in that direction.
Okay, great. All right, unless anyone has got anything to add, I'll move on from there. Okay, I'll take that as a sign to move on. It was actually a submitted question that I wanted to address to you, Miguel, and it was really kind of moving on to some of the wider trends that we see in the aviation industry. And I hear a lot about this at the moment, and that's the movement to cut out carbon emissions and new types of aircraft and materials and flying with zero carbon emissions. Do you feel? What are your thoughts about it? Do you think it's achievable? How is it affecting what you're doing with XYLON and what your customers are doing? Are you?
Yes, of course, we see not only in the aerospace, also in the automotive, that we are moving in a e-mobility. That, of course, the aerospace is part of it. We see that these electrical engines for the narrow bodies aircraft is coming, and we believe that is going to be a very relevant part of our business. And hydrogen, I believe that is going to take a little bit more time because it's not only the technological topic, it's also logistics. What that means at the airport sites. It's going to take, I believe, more time. Of course, we have a look on. But regarding the e-mobility, you can see the e-volts, they are all electricals. You have also the satellites, you have also the electrical topics. And you just can see how Rolls-Royce, all the big, let me say, OEMs are publishing in LinkedIn continuously on daily basis regarding electromobility. And of course, that is moving, I believe, all of us strongly in the direction, especially with computer tomography, sometimes 2D, but that is a very strong movement in that direction. And okay. I believe that we will see sooner than we expect at loss for the narrow bodies and intercontinental flights, a lot of electrical devices.
Does anyone else see their clients dealing with these new types of propulsion systems? Any around electrification, hydrogen fuel?
Yeah, I think it is really coming out there. I mean, the automotive industry is, of course, far along the electrical path, and we see inspection needs on multiple fronts, right? So battery so we tend to think of, we're still growing, I would say, in that new energy space, because we think of electrification, for example, as inspecting batteries, but really it is inspecting an entire energy ecosystem, right? There's the production facilities for these batteries, there is the assembly facilities for these batteries, and that involves new tools, new capabilities that need to be inspected, and so on. Same with hydrogen. I think Miguel pointed out, hydrogen is not just a fuel. It needs to be pumped, it needs to be transmitted, it needs to be, so there is a piping system, there is a storage system. All of those, much like a refinery gets inspected at a shutdown today with, Rick probably knows better than me, I don't know, hundreds of different people using dozens of different equipments and equipment types. That is going to happen for hydrogen, and we need to really address that as a holistic step. And so, to your question, Ben, yes, we are approached happily, I guess.
Yeah.
We are happy that we're getting approached, and I think there is also a lot of technology problems that need to be solved to address these. It's tempting to think you can inspect a pipeline as a pipeline, but sometimes a product matters a lot.
And don't forget, not all hydrogen is green, and that's going to be
indeed.
a very strong fight for getting this hydrogen.
Indeed.
Rick, is there anything you can talk around with this? With your, what are you seeing coming into your office? Into your facility? I mean, what are the common issues that people are addressing? Oh, he's just dropped out. That failed him, that question.
No, I think throughout my career, in a service lab, I think back to simple. It seems simple today, like friction stir welding. At one time, they brought it in. Hey, start doing X-rays on this, and we started seeing things that we didn't know what to call them. Right? We then get the additive manufacturing, where I can get some data, but is it good or is it bad? So no, yeah, we're definitely Element. Like I said, I'm on the non-destructive testing side. Element as a company, starts from the R&D cycle all the way through product qualification at the end, which is why it's an exciting place for me to work. But ultimately, that's where I think the challenge for us, the provider, is, yes, I can find something. How do we collaborate as a group to say, what is an acceptable defect, what isn't a defect? How do we write the standards to make that go? I mean, the technology part, I feel these guys are doing a great job of making some really good tools. Our challenge is, because our product is a certification saying, your product is acceptable. How do we get ahead of that to know what is it? Where's a standard that says I can accept or reject this part based on this new type of information?
Wes, do you see a role for VJ Tech's machines in this? I mean, is it something that's happening with you guys?
Yeah, I mean, this is something that's been in the works for a number of years. I mean, if you go back probably 10 years ago, they started looking at the peak material, composite materials, and everything that they can put into aircrafts to lighten the weight, and then the basically changing out the blades on the jet engines to be able to go with a woven composite material to make it lighter and more fuel efficient. The goal was to gain it's supposed to gain up close to 40% efficiency. Some of them have been effective in getting close to that, and some not so effective. But there's going to be technology will continue to evolve, and we got to embrace it. The nice thing about working in the CT industry, we get exposed to some of the most cutting edge technologies out there. So we're going to see that typically 2 to 3 years before the general public. And that's the great thing about this industry. I think that the technology and what we're doing to push the limits, as I think it was Miguel mentioned earlier, or Naveen, about these products when you're going to additive, going to, from something that's 8 inches to a foot, and you need to see something to the micron level, to something that's 6-8 feet in diameter and made with, 10 parts versus 200 parts, because they're all being printed. And that's what's going to be interesting to see what people do to drive that resolution, from not just the detector side, but also from the tube side, because there's some physical limits. And then what other technologies can be utilized as we see the race to space with SpaceX, Blue Origin, or Richard Branson as well, seeing he was the first one to cross that threshold. Didn't get any credit for it, but he was the first. And the big thing is, when you look at that, is what other testing is going to be needed other than CT? CT and X-ray may cover some of it, but you go back to the NASA days with shearography and how that's used to detect certain surface defects, or even basically Toft and utilizing it for surface cracking and verifying things from a number of different areas. It's the working together of all these NDT technologies that make this industry great. We just are in one of the more the latest on the cutting edge evolving ones, so it's a hot topic, but they all have to work together and have the right area to make sure things are safe.
One of a suite of tools, sure. I just wanted to bring back to a couple of the reader questions here, just to cover them off, just so that no one can accuse us of ignoring them. There's question here about CT not being applicable for in-service work, I guess. He wants to know about 2D X-ray, where at the moment he's using film techniques. He wants to swap to image plates because it's faster and in the end cheaper. I guess that's not really a question. It's more of a statement of fact. Is that something people would agree with?
I would completely agree. And when you want those plates, come and buy them from us. No, but seriously, I think we hear that a lot. We hear customers asking this, that they have cabinets, X-ray cabinets that they do film in today. Can we just swap out a tube and a plate? And to a large extent, it is possible. I mean, there are capabilities to be built, but in principle, there's very little preventing you from doing that.
Yeah, Elements made the switch through computed radiography. So using the flexible plates was kind of our stepping off point from film to CR, and then into the DR world. But today about 50% of our radiography is done digitally versus film, and we hope to keep evolving that. I think our biggest barrier on our standpoint was to building the talent, right? You can't train people until you do it. So we started in 2015 with one level 2 and got up pre-pandemic to over 45, certified level 2 technicians. So that's big part. And actually, this question, and I don't take over here, Ben, but I wonder, you folks that build these great machines, as a guy that went to a trade school for non-destructive testing, have the trade schools got access to the latest technology so that they can help, train that next level of employee that I want to hire, and they're already stepping off with a good base?
Great question, Rick. Yeah.
I think so. We try to push as much as possible, because to us, somebody gets trained at a trade. I mean, it's not a generous gesture. I mean, when somebody gets trained at a trade school on one of our systems, we expect that guy to go to, I don't know, a BP or a Shell or a PCC or a GE Aviation and ask for our equipment to use. And so happily we do that. So that's.
I think some are excelling more than others, at getting that equipment in, and I think it could be us working together on partnerships and collaborating with some of these schools to help the industry, maybe something that would help drive things forward and growing that talent. Traveling the world, I have seen some great universities. I was blessed to have 4 different interns live with me that came from Nanyang Polytechnic over in Singapore, and 3 of those are back in the industry. One working with volume graphics, doing a great job, and one of them running some CT equipment out there, and then the other one working on the inspection level. But I think that's where it's critical, not only just on the school level, but for all of us as a team to get some of these young students of the industry out there doing internships in the summer and open their eyes to the possibilities moving forward. And that way, when they're going back to college, they're getting other people energized and excited about it, which will help grow our industry long term.
Yeah, good to play with that 9 MeV CT machine. That sounds pretty interesting.
Hey,
I mean,
happy to host anybody. No, but I mean, that's the reason we put it at our customer solution center, where we're really trying to make it more democratic, so to speak, right?
That topic is
come use it. Yeah.
That topic is obviously also highly driven by the government. By the rules and the investments of the government. If they want to invest in such tools already in the school. For example, I guess China does a very great job there with their World Skill Games, which they do quite regularly, where all the young top talent engineers can come there, use the newest technology, cutting edge technology, really developing the brand new stuff directly on those new tools coming from companies like ZEISS, like all the others, Mitotoyo, whatsoever, whatever the name might be. And I think, it's always for us companies, it's always a little bit difficult. Of course, companies are meant to make some money. Oftentimes, it's in these areas there is not so much money in, but obviously, I myself. I came to ZEISS as I was already working with a CT in my university, and therefore also I joined ZEISS with the knowledge I already acquired there at the university. So I'm like one of those trained people, trained in the university on such a system, and yeah, now I'm applying it in real life.
That's a perfect example right there.
Yeah.
And look at where you are today. That's awesome.
Just a small point from me on this, maybe. I mean, isn't using these machines in these capacities in research and academic institutions, doesn't it help to push the technology itself on, the tools and technology?
Yes, indeed.
You know, it helps encourage innovation.
Yep.
Yeah.
I think
So
so. I think some of
Okay.
the key innovations that we've seen have also come from people who have come back and said, "Can you do this with your system?" And then we're like, "Hey, that's a cool idea." And then we go back and build those things.
those partnerships are often very successful. So I just would like to take this opportunity really just to give everyone a chance to sum up. I mean, I'm going to have a go first because I think it's been a very interesting discussion. We've had a very varied discussion as well. I mean, we've gone into some technical detail around infrared thermography and fatigue cracking. We've talked about the suitability of CT compared to other tools. We've talked about where we can use CT and other types of tools. We've had lots of discussion from different perspectives from suppliers and people, both clients and people that are using these tools every day. We talked about automation and automatic defect recognition, remote reading, and also how even those technologies can help with labour shortages. We've also talked about digitalisation and how we can help. Those tools can help people become more efficient with testing and more effective. So, and also hydrogen and electrification, how those trends in aerospace are affecting us. So, wow, I mean, it's an hour, nearly an hour and a half. So it's a lot of topics. But I mean, I'd like to just go around the panel just to give everyone a chance just to sum up and say goodbye. Really, Miguel, do you have anything to add? We'll go that way around.
Yes, I would like to add something maybe relating to this new space, but we call it so. That these small satellites, eVoLTs, is bringing a new era in this industry. So that is, we are moving from the classical big ones, Airbus, Boeing, and the supplier chains. Suddenly, we have a lot of defense opportunities. We have the satellites where almost every university around the world are putting satellites in the world. I was in a couple of webinars, and it's just amazing to see. They can see what is the temperature on the Baltic Sea and the 40 meters deep in the sea, just with the special sensors. And that's is in this movement, the the space. A lot of countries are coming now to these new opportunities in the space. They need electronics, they need additive manufacturing. We can see also that launches companies, they are growing right now. And that is really a very amazing, nice dynamic, maybe because I start to be in an age where I really enjoy to have discussions with people from the university. That is very refreshing. And they have just sometimes absolutely new approach where we can learn a lot from all these new people. And I can, to you, Wes, I fully agree. This kind of collaborations, I enjoy personally, and I believe every company needs this fresh air from the young people. And at the universities right now, they are looking a lot in this new space, and we have to use this opportunity for sure.
Fantastic. I'm going to move quickly on to Rick so that everyone gets a chance to speak. Rick, what are you going to take away from today?
Brief. Yeah, no, I think I'm a little different than the people on the panel here. I mean, Element is a testing company. We rely on you folks to make the modern technology, but we bring it to the market to keep things safe from aerospace, which is a huge part of our business, to the oil and gas, which we're protecting the environment, also protecting people. So I've been with the company for 20 years and enjoy that aspect that we're there to keep the world a safer place and look for you guys to continue to build me the tools and help us partner together to keep the talent pool going to keep the industry moving forward.
Great, thanks, Rick. Naveen, briefly in a minute, how would you sum up?
No, I think as an industry we've come a long way. I still remember my first job where I was inspecting binding machines, and I would literally look them over, compare them against a document I held in my hand, and literally push them off the line if they were bad. From there to today, we're talking about CT machines and connecting data and so on. We've come a long way. I think it's a really exciting time, and I wanted to thank you and everybody else here for the opportunity to talk about this. So it's very, very exciting.
Great stuff. Thanks, Naveen. Thanks for your input today. Wes, you want to go?
Yeah, I first would like to say that the best part about this, and this is a collaboration. You have some of us that are peers, competitors, but we're doing everything to work together to deliver a better product for our customers. And the customers' issues at hand, when they have a problem or an issue where they're trying to solve something, there's a lot of talent out there. And it's important for all of us to work together to make sure we're doing what we can to drive this industry further into the future. And we mentioned numerous countries around the world where it's getting very difficult even to get product from different places. So it's critical to be able to manufacture, most likely on in different parts of the world as well. And I think that's going to be one of the challenges moving forward, is making sure that the companies are set up to service all sectors of the world with their products, with talent, and growing that talent in different locations across the world. I think Benedikt covered that earlier, and it's great to see that you came from a university setting where you were brought up and into a role at an expert level nowadays. So I'll turn it over to Benedikt.
Thank you, Wes. Benedikt, you have the last word, Benedikt. Go for it.
Thanks. So I'll do a quick ending. I think we have talked now in length on various different questions. I think that we haven't covered all. We could go on like forever. So I just want to encourage you, the audience, in case you have any questions, feel free to contact me as well as all the other experts too. I guess I can only speak for ZEISS. We as ZEISS, we put the customer application, your issue in the center of what we do. So we're always trying to solve your issues. So in case you face any issues during your daily work and seeing trouble with the parts you manufacture, please feel free to reach out to me or any other ZEISS colleague. We most likely will have a solution which fits to solving your issue.
Great. Thanks. Thank you so much, guys. I appreciate your time so much and your support to help make the event happen, the online event happen. And I hope you got some value for it. I hope some of the audience has as well. They've got value from it as well. It will be available. So everybody that's registered will get an email shortly saying that they can watch it again, and then it will be available on the aerospace-testing-international.com website to view as well. So if you want to review it or it's available to watch again. Great. Thank you so much, everyone, and enjoy the rest of your days wherever you are. Thank you.
Thank you.
Bye.
Thank you.
Have a great day,
Have a
everyone.
rest of the day. Bye-bye.
Bye.